Alrighty, so today what we're going to talk about is encapsulation, and really what we're talking about is just kind of a basic introduction to objects, how objects work in Java, what you can do with objects in Java, things of that nature. I understand that some of you have probably already done some work with objects before, which is great. That's actually excellent. I'm looking forward to hearing some good questions from you folks that have already played around with objects a little bit. If you haven't played around with objects yet, no worries. That's kind of what we're all here for. I'm going to walk through hopefully a few coding examples to show you. And then too, just like these videos will be online, I'll push all of this code to you that we work on as well, so you can reference it as you're working on problem sets and other things. So let's talk about objects. Objects are actually the building blocks of Java. Everything in Java is an object. And an object is specified in a class. So you can think of a class as a template for an object. We'll talk a lot more about that whole structure a little bit later. But the first thing I'm going to do is create a new class file for us to kind of play around with for the duration of this lecture. For those of you who haven't played around with this tool yet, this is IntelliJ. This is it's called an IDE, an Integrated Development Environment. That provides you a lot of tools and functionality for programming to make things faster and easier, essentially. I'll try and show you some tricks as we go through, and I'll make sure after this lecture is over, I'll make sure that everybody can get this set up before I leave today. But you'll be using this basically from now until the end of the class to write your code in. So up at the top, you see I've got a little folder up here called Encapsulation Lecture. So I'm going to go ahead and create a new class. Actually, in order to do that, let me expand this real quick and see. Yeah, so I need to do that here on the source. New Java class. It asks me for a name. So each class has a name. The name of your class file should always be the same as the object that you're trying to create. So already we kind of have a decision. We need to decide on an object that we want to kind of piece together as a group. If anybody has any suggestions for objects, I'd be happy to solicit suggestions. If not, I have a few ideas of my own that we can try to do. Anybody have an idea for object? It can be literally anything, preferably something, you know, physical, not super abstract, preferably something that has some actions associated with it. How about a computer? Let's try it. Let's try it out. So you see the name of the class is computer.java. That's going to be the name of the class file as well as the object that we're going to create. Okay, so I'm going to go ahead and click OK. I'll explain Git a little bit later. I'm not going to worry about that right now. And you can see that IntelliJ has provided me with a basic template. Whoops, except I did that wrong. Sorry. I named my class file incorrectly. Let me delete this and start over again. I'm not sure why that happened. I must have selected the wrong thing. Okay. I know what I did wrong. All right, one more time. I promise I'll get it right this time. It doesn't want the, it just wants this part. There we go, perfect. Great, so we can see that the very first part of our class is just telling us that, hey, we're making a class, it's called computer, okay? So I'm gonna give ourselves some space to work here. Every class has two basic pieces, two basic things that you can specify about it. So we've got attributes or properties or fields, right? And these are going to be things that describe our class. These are also going to be nouns. The name of our class is a noun. These attributes, these properties are also going to be nouns. So who can think of some nouns that we might use to describe our computer? What does a computer have? What kind of properties? Keyboard, okay. Start typing these in. What else? Memory? Perfect. What else? I'll just call it screen. Yep. What else? Any others? Processor. Yeah. And I'll come up with a few of my own. They'll have like a brand, right? Brand name. Trying to think if there's any others that we could use to our advantage here. This is a good starting point anyway. So this is a list of attributes. We can always add more later if we come up with some other ones. For each of these attributes, these are going to become essentially variables that we can reference within our class, just like we would reference other variables that you've seen in C, for example. However, it's a little bit different. So, we have to specify a type for each of these, just like we'd specify a type for our variables. Some of these are going to be a little bit tricky. Like for keyboard, can anybody think of what a good data type would be for a keyboard? How are we going to represent this keyboard in our class? Yeah, that's kind of what I was thinking was a string. We can kind of use that as a descriptor there. I'll put a semicolon on the end. Memory, what might be a good value for memory? Good data type? I'm sorry? Integer might work. Yeah, we can use that as the number of gigabytes of memory typically, or megabytes, depending on how new or old your computer might actually be, right? Screen, so screen was listed as size. If we want to list this as screen size, we actually have maybe two properties here, a length and a width, right? Which we could represent as some kind of numeric value. Or you could do the diagonal. Yeah, that makes it easier for us. That way it's only one value. What would be a good data type for that? I think a float or a double would be more appropriate there. Processor, how do we measure processors in our computer? So megahertz, gigahertz, yeah, so that's also going to be a number of some sort, so perhaps an int, right? And then brand is, I think, clearly a string. We add semicolons after each of these here. So that's our first decision that we have to make about each of these attributes, is what their data type is. We also have another decision to make about each one of these attributes, although it's an easier decision to make. You see, Java includes these keywords that you have actually seen before in C, right? Public and private, or you might not have actually seen private so much. But I'm going to mark each of these private. In fact, best practices state that you should always keep these properties private unless you have a very, very good reason to make them public, which is the other option. So your default behavior for all of these should be private. And I'll explain, actually, I'll explain why that is right now. Keeping these private is sort of the whole goal of encapsulation. I can use a computer object without knowing how the internals of it work, right? It's like a black box. I can give it things as input. I can take things from it as output. How it actually works underneath the covers is not my concern, right? It's our concern right now since we're writing the class, but after the class is defined and we actually are creating these objects and using these objects, we don't need to know the internals of these values, right? So this is a good list of attributes for us to start on. Yeah, that's a great question. What does it keep it private from? So if I create another class, another object that wants to use a computer, you can think of these as being similar to values that are accessed in structs, fields that you access in structs. By keeping these private, I can't access these values outside of the class from a different file, for example. I can only access them within this particular file, within this particular class. So it's keeping it private from everything except for ourselves. I'll show you an example of that later once we get a little bit more code on the screen. Yeah, so you actually that's a great question. You actually probably wouldn't publish the list of attributes so much. There is a way of granting access to these attributes, which we'll talk about very, very shortly. Sometimes it is beneficial to provide access to these, whether you want them to be able to read the value or change the value of the attributes. And I'll show you how to do that in just a little bit. The next thing I want to talk about actually is a very important piece of every object. So in order to create objects in Java, we have to utilize a special method. And that method or function, as you probably are used to hearing it called from C, is called a constructor. So every class that you write should have a constructor or maybe even multiple constructors. And the purpose of that constructor is to create a version of that class. So I'm going to go ahead and create a constructor for you right now. You'll notice I am calling it public. I do want this to be accessible from the outside world. And the name of this constructor is going to be the same as the name of the class, computer. That will always be true. The name of the constructor will always have the same name as the class that it's in. The purpose of a constructor is very simple. By the time the constructor is finished, the constructor is just a method, just a function, right? By the time the constructor is finished, all of these attributes, all of these properties should have values. That's the purpose of a constructor. So where those values come from could be several different sources, right? I can accept values as inputs to my constructor, which is actually what I'm going to do for a lot of these. What did I say? Int processor. What was the last one? String brand. Thank you. Let me just call that. I know I'm off the screen here. Let me see if I can squish this so we can see most of it anyway. So you'll notice I listed all of the attributes as inputs to this particular method, this particular function. And so in order to actually set these values, to my attributes, I can just treat it much like I would treat variable assignment. But you'll notice that it's going to be a little bit different. In order to access the attributes, I'm going to prefix them with the word this. Whenever you see the word this, you should think I'm referring to something within this class. This is always pointing at an attribute or a method within the class that you're currently in right now. The reason that that's important is notice that the names that I use as my inputs happen to be, in a lot of cases, the same as the names of my attributes, of my properties. If I don't prefix this the attribute with this statement means something totally different. It looks like I'm assigning the input to itself, right? It can't distinguish. You'll notice that when I put this in front of it, it changes the coloration of the name to purple to indicate that it's actually referring to one of these attributes and not the input parameter to the constructor. So it's very, very important to prefix your references to properties, these attributes with this. Now, I'm just going to go ahead and fill the rest of these in real quickly. Let me do them in order, or try to. Just remembering to prefix them with this. Screen. This dot processor. Now I'm going to show you this next little trick. You'll notice that for brand, the name is different. The input parameter is actually B, and the string is called brand. So in that case, I can actually say this I can actually say a statement like this without the this in front. Notice how brand is purple. There's only one brand that I could possibly be referring to right now, right? There's only one brand that exists. Even though you can say statements like this, even though it's perfectly acceptable in Java, I still like to include this just so that it's absolutely 100% clear. This is a property of my class. This is a variable that I'm accessing within my class. It's not one of my input parameters. And so we've successfully created a constructor for this particular class. Again, the purpose of a constructor is to make sure that every one of these properties has a value by the time the constructor is finished. And we've accomplished that goal, right? We took all of these values as inputs and we've set them to properties. We're getting very close to being able to actually test this out. I just want to add a couple more methods first, and then we'll try and test some of this stuff out. Earlier, a question was asked, how can I reference these if they're all private? The way that we do that is with a special set of methods, a special set of functions called accessors. And accessors come in two flavors. You might hear them referred to as getters and setters. They follow a pretty standard format. I could say public, which one do I want to do? String get brand. And this is going to be one of the easiest methods, easiest functions that you've ever seen. I'm just going to return this.brand. I've now provided access to one of my attributes through a method, right? Think about what this allows us to do. I've kept all of these hidden. All of these are hidden from the outside world. If I need to provide access to the outside world, I can create a method to give this value to the outside world. If I don't need to pass these values to the outside world for any reason, then I just don't create the method. I don't create a getter. Just an example, a quick example of a setter. If I wanted to create a setter for this same, I need to take in a string, right? What do I want to set that value to? And then actually set it. Oops, there we go. So we can think of, using private in conjunction with getters and setters gives us a lot of flexibility over these attributes, over these properties. Getters allow me to read attributes. Setters allow me to write to attributes. So I can control the read-write access for each one of my properties, each one of my fields on a case-by-case basis. Is that clear? Does that kind of make sense? We'll see this in action. I haven't been able to test this code. I can actually test it now. So let's test this out. What's the entry point into a program in C? Main. The same is true for Java. So that's a nice thing. Here's what this looks like in Java. It looks very similar to a main method definition in C, right? A little bit different, but pretty similar. It's still called main. This is a pretty standard main method. This is going to be the entry point to our program. And all I want to do with this main method is create a computer and then see if I can access the brand, see if I can get this brand out of it. So to create a computer, it's just like creating any other variable that you've ever done before. What's the first thing that you type in when you want to create a new variable? The type. The type in our case is going to be computer. We're creating a variable to represent a computer, an object. What's the next thing you type in for a variable definition? The name. So I'll just call it C. This is where things get a little bit different. I have to use a special word, new. New indicates that I'm referring to a class. New indicates that I'm about to call the constructor. I'm about to call this method, this function. So let me type the name of the method. And now I have to provide it with inputs. So for keyboard, I'll just use my computer as a reference. I've got an English keyboard. I've got 8 gigabytes of memory. Screen size is what, 13.5 inches. I don't know if that's true or not. Seems reasonable anyway. Processor, I have no idea what that is. I'll just put a really big number in. And the brand is Lenovo. So I know I'm kind of off the side of the screen there. Let's see. That works pretty well. You can see almost all of it. Okay. There we go. Perfect. If I want to see how these getters work, I'll simply call a method on this object. So this is what we call an instance of our object. I'm now going to call a method on this object. In particular, I'm going to call getBrand. You see getBrand has a return type of string. So if I actually want to see this, I can print it out to the console. Like so. And now this is actually in a position where we can run this and see what happens. Let me run this. I can just click the little green triangle up here, and it should run for me. Unless I made a mistake, which is entirely possible. Yep. Well, that's not what I wanted to run. So let me, it ran a different file. Let me run this one. Oh, missing return statement. That's okay. Actually did this incorrectly. This should be void. Sorry about that. Setters typically don't have return types, so that was my bad. That was my mistake. You can see IntelliJ told me that I made a mistake, so that was an easy one to fix. Let's try this again, see if it works for us this time. And I know it's hard to see. Let me see if I can't zoom this in any farther. There's the brand name of the computer that I supplied, Lenovo, right? So it successfully retrieved the brand from the object. Now, this is, somewhat useful on its own, but to really illustrate the usefulness of objects, you need to understand that this is an instance of the computer class. This computer class is a template. This template can be used to represent any computer that I want, any of them. If I want to represent a different computer, I just create a new instance of that computer. Let me show you what I mean by that. I can come down here and create another computer instance. This time I'll create one to represent your laptops, these MacBooks. Again, I just call the constructor. This time I'm going to supply different values, right? Some of them will be the same, like the keyboard, for example. Some of them will be different. I don't know the specs for this computer. I'm just kind of guessing, right? But the last one here will be Apple for the brand. So now I have two computers. They both relied on this same code base, right? So I reuse this same class to create a different object. I now have two computers, two instances, one called C, one called Mac. And so what you'll notice is I can write another line of code that uses my second instance down here. Instead of saying c.getBrand, I'll say mac.getBrand. And now when I run this code, you'll see that it still prints out Lenovo for my machine first, but then it prints out Apple for the second one after that. So what happened? These attributes are being stored separately for each instance that I create. And when I call these methods, this is saying, what is the value of this attribute for this particular instance that I'm calling this method on right now? Does that make sense? That's one of the trickiest concepts, I think, to pick up about objects. I'm reusing this code. I've got many different computers. Whenever I call these methods on one of these objects like this, it's referring to the properties, the values of those properties for the instance that the method is called on. Are there any questions about this? You guys got real quiet. Correct. It stands for a specific instance of an object. Yeah. So when I call c.getBrand, right, this refers to C. When I call Mac mac.getBrand, this refers to Mac. And so it's going to look up the value that I supplied, right? Which is different. The values that I supplied are different. They're different computers. They're different instances. And it'll return the one that's appropriate for that particular instance. Yeah, that is a little bit confusing. If it makes you feel better, you can actually create a separate file for main. That's actually perfectly okay. The nice thing about, so main is like a real special case. I think of main as being sort of classless. It just kind of exists out there on its own. However, in Java, everything has to be in a class. Classes are not optional. You cannot create a Java file that does not contain a class. So main is going to be in some kind of class. I think it's useful actually to have lots of mains to test. I can stick a main into every class if I want to test the functionality of that particular class. So don't be afraid to drop a main method in wherever you want, pretty much, and run that main to test your class. So in order to provide this with a lot of functionality, right? Question, yeah.
So in this file, we can create another class that is
Yeah.
And then that also has a
So okay, let's. That's kind of a two-parter. The answer to the first part of your question, could I create another class in this file? The answer is yes. However, that's kind of an advanced concept that I'd encourage you to stay away from for now. For now, I'd like you to focus on one class per file. If the classes are in the same folder, I can access them, right? To answer your second question, could that second class have a main? The answer to that is no. I can only have one main per file. Yeah. So. Right. No, I understand. I understand. It's very different. Yeah, it's a lot different. Right. Typically, each object is going to have its own Java file, right? So if I have a program that requires 3 objects, I'm going to have 3 files, and they'll all communicate with one another. I'll actually add a second file to this in just a little bit and show you how that works. There's just a couple things I want to do with this object before we try and move on. Yeah, of course.
That's two questions, actually.
Sure, yeah.
So in general, do all the main declarations are like that?
Yes. Public static void main. In one of our later lectures, well, you already know what void is, right? You probably haven't seen static before. That's maybe a new word. For now, just kind of treat it as magic. Later on, we'll talk about what static actually means. We'll see that maybe on Thursday, actually. But for now, just treat it as kind of the magic word that main needs to do its job.
And with the string args.
Yeah, so string args, you've actually seen something similar to this in C. This is an array of strings that represents the input arguments to the program. Typically, if you're developing through IntelliJ or other IDEs, you won't use these very often. If you're developing on the console, which you can do, I'm not going to spend a lot of time developing stuff on the terminal, on the console. You would use args a lot more often. In that case, it's still required. It's necessary even if you don't use it. Yeah.
And then my second question is, it looks a little confusing that for your setter, this brand equals is the same as a line in the constructor.
Yeah.
So I guess the constructor, you're just building. You're not
Right.
actually acting. It's not actually, like, it looks like this brand already is being.
Right.
Why couldn't you return this brand?
Yeah.
In that setter?
That's a great question. This is actually something I wanted to talk about next anyway. So thanks for the lead-in. This is perfect. So the constructor, as I mentioned before, the constructor is like bringing an object to life, right? How many times is an object created throughout its lifetime? Once, right? I create an object one time. So the constructor is only ever called once per object. One time per object, right? Exactly once. This method down here is not a constructor. I can use this method however many times that I want. So in this case, it might be a little weird to think about changing the brand of a computer. That typically doesn't happen. But let me just show you an example of how I could use that method anyway. Let's say that I'm envious of your computers and I wish that I had an Apple, right? I can call setBrand. Oh, sorry, that's not what I wanted. I can say c.setBrand and then provide it with a new brand, in this case, Apple. And now if I print out the brand of my computer again, I should see that that value has changed because the value that I passed in is being stored as the property. I've effectively changed it. I've written that property. Whatever it was in there is now gone. So let me run this for you and show you the result. So we see here's the original brand. That's your computer, but then this is my computer again. We can see it's the same object. But when I say get brand on it now, it takes the new value that I passed it through set brand. And if I wanted to change it again, I could call set brand again and assign it a different value, and it would take that new value in as a property. So that's the main difference between the constructor and other methods. This is a one-time deal. This is a one-shot. Constructor is always called the very first thing, only one time per object. The other methods can be called as often as I need them to be.
Can you add attributes to an object after the object's been created, or do you have to create an object?
You cannot add attributes to an object after it's been instantiated, after it's been created. However, I can always come back to my class if I want to and add a new attribute, right? If I do that, what do I need to change? What do I need to update? I need to change my constructor. Why? What's the purpose of a constructor? To set the values for all the attributes. So if I add an attribute, I have to change my constructor to set a value for that attribute. Good. I'm going to take this off, actually. But yeah, I mean, it's very common. You're not going to get every single property right away. It's very common to have to come back and add more later. Just remember that you have to change your constructor accordingly. Let me think. What did I want to do next? Oh, let me create another file, actually. I'm going to create another file. I wanted to show you, I promised that I'd show you how private works. So let me do that real quickly, and then we'll move on to another thing. I'm going to call this computer tester. This is just going to be a real basic, real basic class. In fact, I'm not going to treat this like a normal class. I'm basically going to treat this like a container for a main method, actually. So let me just steal actually part of this main method over here. Copy it in. I've created my computer in this new class, in this new main method. If these were structures like you're used to working with in C, if I wanted to access one of those properties, one of those attributes, I could say something like C.processor, right? Say something like this, and it would give me the value for that processor. Maybe I could try to print it out. Right. So tell me what the value is for the processor. It should be what? This giant number, right? Well, let's run it and see what happens when I try to do this. You'll see that it gave me an error. Processor has private access in computer. I cannot reference it this way. I cannot reference it like I would a structure, like I would a field from a structure in C. If I want to grab this value, I have to provide a method
that gives me access to that value. Just like I did for brand, I could come back in here and create another accessor. Processor, right, that just returns, if I can type, this dot processor. And now I can go back into my tester class. Instead of saying c.processor, I'm going to call that accessor method. And now I should see, whoops, it didn't run the right file. Sorry about that. Let me run this file instead. There it is, right? So that's really kind of the whole point of encapsulation, is I can hide those values from other people, from other classes, if I determine that other classes, the outside world, might need to access those values. Then I can provide methods to give them access to those values. I can write accessors. It allows me to control, do I want them to be able to read this value or write this value or both, right? I can choose the appropriate methods. If they don't need to do either, then I don't write the methods at all. I just say, forget about it. You don't need to know what this value is. It's only for my internal purposes, right? Any questions about that before we move on? Okay, cool. I've got just a couple things, a couple other things I want to show you about these. So at the very beginning of this lecture, I mentioned that classes have two basic pieces. The properties, which we've already spent a lot of time talking about, right? Go away. What is that? There we go. The other part we've already been working with, methods. But we haven't really written any particularly useful methods so far. We've written accessors, which are very special, kind of limited usage types of methods to provide access to the properties. But you should also include methods that provide functionality for your objects. So I think of the properties as being nouns. We say that these properties form a has-a relationship. I say computer has a keyboard, computer has memory, computer has a screen, right? That tells me it's a property that has a relationship. But a computer can also perform actions. What are some things that a computer can do? What are some verbs that you can do with a computer? Yeah, so arithmetic operations, right? You can, I mean, you can check your Facebook, you can go online, you can watch cat videos on YouTube, right? Computers can do lots and lots of things. Let me show you an example. One thing that I like to do with my computers, if I can afford it, is add more memory, right? I like to upgrade the memory. So I might create a method called add memory. And if I want to add memory, I need to know how much memory I actually bought, how much memory I actually, you know, am adding. So I'll take an int, and maybe I'll label this new mem, just so I know it's incoming memory, right? So I've got this method, add memory. And I just want to take my current memory value and add this new value to it. How can I say that? Does anybody know how I could say that? Yeah, this dot memory plus new mem. Yes. Perfect. You could do plus equals. Yes, that would also work. Yep. And so this would effectively update the memory for this particular computer, right? This will take in a new memory value and change the properties of this computer. Let me think if there's something else that I could do with this particular example. Screen, processor. I'm trying to think of other actions that I could code that are relatively simple with this example. I can add memory. I can This, I'm sorry? Oh yeah, sure. How would I actually use this? Let me go back down to my main method here and add some memory to one of my instances. C.add memory. And then I have to supply it with how much memory I'm adding. Let's add 2 gigabytes, right? Notice that this looks a lot like the setter that we saw before. I want to do something to make this a little bit different from the setter, because typically a setter is going to be a simple one-liner like this. Other methods like this, the actions that I can form, will be more complicated. Anything that I want to use within here, I can. Any constructs, any programming constructs that you know. So I can use loops, I can use if statements. I can call other methods within this method. So let me show you an example. Let's add a sort of arbitrary limitation. Let's say I can add memory, but I can't go above 8, right? I can't add memory above 8 gigabytes. 8 gigabytes is going to be my cap. So if I want to enforce that limitation, I can write an if statement. I can say if this.memory is less than 8, then perform the operation. Otherwise, I don't need to do anything, right? Just leave memory at what it is, cap it at 8, right? Although you have to be a little bit careful if it was 7 and I added additional, right? So what might be a better thing to say here if I want to cap it at 8? Plus new mem, yeah, that's good. This.memory plus new mem is less than 8, then go ahead and perform the addition and assign it, right? If I wanted to, I could add an else here that says, you know, print out a statement that says, okay, max memory reached. And so I really wanted to illustrate a setter is almost always going to be a one-liner like this. Other methods within the class will typically be longer and include other functionality, right? If statements, loops, method calls to other things, right? And so these kinds of things these are going to be the methods that are most commonly used. The getters and setters will be used frequently as well, right? These are going to be the actions that an object can perform. I think on the practice set, for example, I gave you a problem set for a bank account object. So like a bank account object, what actions can it perform? I can do withdrawals. I can do deposits. I can compound interest, things like that. Those things become methods. So nouns that describe an object become properties. Verbs that an object can perform become methods. That's a very important part of the design process. Okay? Yes?
You say, you said Peter has a screen, you say what the methods.
Yeah, there is no clever phrase. I mean, can do might be, it's a verb, it's an action. Yeah, that's the best way to think of it. Oh, yeah, yeah.
And the other thing is just a question.
Sure. Oh, right. Yeah, that was actually unintentional. Print ln stands for print line. So it puts a return after it to move to the next line. Print does not add the line, so it'll just keep printing everything on the same line until you tell it to print line. I actually wanted this to be print line. I just didn't type it in. Yeah, good question. That's a great question. So the question was, why is the S in string capitalized but the other types not? These are called primitive types. Ints and doubles are primitive types. String is actually not a primitive type. String in Java is an object which means there is a class, much like the class that we're looking at, that defines a string and what a string does. So a string has properties, just like this class has properties. A string has methods associated with it, just like this class has methods, right? String is kind of a special case when it comes to classes because it's so commonly used. What's the primitive type, actually, that you would expect to find in a string? A char, yeah. Or char, depending on, potato, potato. Right? And so char does exist in Java as well, but almost never used. We'll almost always use strings instead of chars. They're just more convenient to work with. The days of char star are gone. Pointers are gone, right? Notice I haven't used a single pointer. Pointers are gone. Java doesn't have them. Everything in Java is a reference. Everything. And Java handles all of that stuff behind the scenes for you so that you don't have to worry about it. Notice anything else missing from Java that you had to do in C all the time? Think about, this is like an allocation statement. That's kind of the equivalent of malloc. Using new is sort of the same thing as malloc. Not quite, but pretty close. There's no deallocation, right? I don't have to delete things. I don't have to destroy them. Java has garbage collection, which means it handles all of that for you. So Java is a very convenient language for that reason. I don't have to destroy my objects. What else did I want to show you? Let me think. Let me show you one other thing with this particular method. I actually haven't used this method yet. Let me actually try to run this. I had 8 gigs to begin with, and I'm trying to add 2 more. That should trigger this statement, right? That should trigger this else. So let's just make sure that it works. And then I'm running the wrong thing. Let me switch it back to computer. It always runs the thing that I don't want to run. Max memory reached. Yeah, it worked. Let me show you one other thing about this class. This class is very incomplete, by the way. A good exercise might be to try and, add some additional actions that this class could do, add some additional accessors for this class. I'm going to add one more accessor really quickly. I'm going to say public void set memory. Because there's one other thing that I want to show you about this, about classes in general, and then we'll move on to one final topic. So a setter, what's that going to look like? Setters are almost always the same thing. What do I need to type here? You can kind of see it actually. This dot processor, or memory, sorry, equals mem, right? What I want to do now is actually, instead of this assignment statement, I want to show you how I could actually call set memory here instead, right? So I can call a method within another method within classes. Let me show you what that looks like. Instead of using assign, this is perfectly okay, by the way. I don't want to tell you that this is wrong. This is actually perfectly fine. This is just a different way you could do it. I could say set memory. Oops, and I got an extra semicolon in there, right? And actually, just like I did with my properties, because this method belongs to the current class, I'm going to stick this out in front of it. It would not matter. It would still call set memory. It would still find the method, right? However, I think it's really good practice to type this in front of your properties and your method calls within the class. It's very convenient to make this explicit, especially when we get to some more advanced concepts like later this week. I'll be talking to you about inheritance and other things. Using this will become especially important at that point to make it clear exactly what we're referring to. Okay. Let's see. What did I want to do next? This is not complete, but I think I'm pretty much going to stop here unless there are any other questions. With this particular example, I'm going to move on to another shorter topic. The other thing that I wanted to show you, and you'll need this for the problem set 2 is unit testing. So unit testing is an idea that I can write code to test my code for me. So we kind of tested our code down here with our main method, and that's still good. You should still do that, right? Unit testing is not a replacement for creating a main method and testing out your code. You should still do that. But unit testing is very convenient because it's automated. So the code just runs for you automatically, and it gives you check marks if the tests pass, and it gives you red X's if the tests fail, right? Typically what I like to do, I didn't do that in this particular case, but what I like to do is write tests first that describe the behavior that I would like to see, and then run the tests as I construct the class to see how well it's actually working, to see if I'm meeting my expected behaviors. This time I didn't do that because I wanted to show you objects first. Next time I probably will write some tests first. IntelliJ is very helpful when it comes to constructing tests. I can right click and say go to test, and it will create a new test for me for this class. You see, right? I've got class name as computer test, which is a pretty good way to go. We're going to be using JUnit 4 in this particular course. There's many different ways of testing out there. We're going to stick with JUnit. It's a pretty popular one to use. I think this will be okay. So let me just go ahead and select OK. And so again, it created a class for me. This class is going to look a little bit different. So unlike the previous class, I'm not going to set up any properties, although I could if I wanted to, I suppose, but I'm not going to. I'm also not going to create a constructor for it. All I'm going to do is write tests. And I'm going to cheat a little bit just so that I don't get this wrong and refer back to this example here. You see that I've got some imports up at the top. This is much like the includes that you're used to from C. So I'm going to steal these from this existing test case and copy them into my tests up top here so that it has access to JUnit. You'll also notice that there's this new word out here, extends test case. That's we're going to treat that as kind of magic right now. That's actually the topic of the next lecture I want to talk to you about. We're going to cover extends in detail. For now, just treat it as kind of like the magic words necessary to test your code. And we're now ready to start writing tests. So I'm going to say @test and define test. What do I want to test? So what things are testable is a good question. You should really write a test for every method in your class. There are some exceptions. Accessors, typically you do not need to test because they're just so simple. But any method that does anything, anything that's non-trivial, like this add memory method, should have a test written for it. Also, I kind of like to write a test for my constructors. Some people will tell you that's not necessary. I think it's good practice, at least for now, to write tests for your constructors. So let me do that first, and then I'll also write one for memory as well. Okay. So to test the constructor, what I'm going to do is I'm going to call the method. I'm always going to call the method that I'm testing inside of the test. Otherwise, it's not a very good test, right? So I'm going to create a new computer and provide it. This is my constructor, right? I have to provide it with the appropriate values, the appropriate inputs to create a computer, which were, I don't remember. I need to look it up. Keyboard, memory, screen. So, okay. Let's do Spanish. Right. Memory will be 6, 5, whatever. Screen. What were the last two? Processor and brand. Processor is an int, brand is a string. 10. test the constructor. What can we actually use to test our constructor? The purpose of a constructor is set values. I know I've asked you that question, but it's so important. So if I want to see that the values actually made it, what can I use to test? What can I use to check that those values are actually there? The accessors. I can use the getters, right? I don't have getters for all of them. I only have, what, 1, 2, get brand and get processor. So those are the only ones that I can actually test, right? So I'll just do those 2 for now. I'll leave it as an exercise for you to add some additional getters and update this test a little bit later if you want. So I'm going to call get brand, but I want to make sure that it actually got the value that I set here, which is Apple. In order to do that in my tests, there's a special method that I can call called assert equals. So what this is saying is call the method and compare it to this value that I know that I'm expecting to get back from that method, right? These should be the same. If they are, then this test passes. This is actually a test, right? And I can do another one for get processor. I can say assert equals c.get processor. This is our first test. Very, very simple, right? Testing our constructor. We also tested our getters in the process, right? So it's kind of a combo deal. Let's run this and see what the results actually look like. Whoops, what did I do wrong? Oh, does it not have the access to JUnits? Okay, unexpected issue. Let's see if I can fix this. This is the kind of thing that I want to help make sure everybody's got set up before I leave today. These kinds of issues. Oops. Dependencies. Yeah. So I want to add. That's not right. There we go. Apply. Let's see if that helps. I'll explain that to you later once I help you set up your projects before I leave here today. Yes. Yes, you can actually see that once I made that change, I basically told it where to find the testing framework, the testing code. So once I told it where to actually find it, it's happy now. I should have noticed that earlier. I missed it. So we can try it again. Run computer tests. I expect it to work now. And so we see that when I run this, the output's a little different. It tells me all tests pass, right? Let me show you what a failure looks like if I come and change this value to something that I know is incorrect. Let me show you what this looks like when it fails. Right? So we can see it expected 10. Oh, actually, I got these backwards. Sorry. It expected 5. The actual value that it got was 10. My mistake. I do that a lot, actually. The value that you expect comes first. The method that you're testing comes second. Now if I try it again. There we go. It expected 5, but it got 10 back. So the test failed. And it tells me exactly which test failed and what the values were that caused it to fail. So if I wanted to, this is to test my constructor, right? If I wanted to, I could actually write a more meaningful test for that add memory method. Right, so what do I need to do in order to test this? Well, I need to create an instance of computer for it to work on, right? So I'll create this. You'll see that the memory I gave it is 5. So if I add 2, for example, or 3, it should actually add it. If I add more than 3, then it should not work. It should keep the memory value constant. So I want to test both cases. I want to test both paths through my method. I want to try and test as many possible options as I can. So let's test the successful addition first. If I say c.addMemory, if I add 2, I can then write an assert equals where I expect the value to now be 7. If I have a get memory, I don't have a get memory, so I need to add that accessor in for my test to work, right? You see I don't have that yet. I should really have done that ahead of time. This is good design, though. I don't add the getter in until I actually know that I need it, right? A lot of cases I'll need it for testing purposes. Now it should work. And then I'll try and add more memory. Actually, if I say c.addMemory again, add 2 more, that should fail, right? Because 7 plus 2 is greater than 8. So it should still be at 7 after I do this, right? Does everybody understand that? So I can actually reuse this same assert equals statement because that value should not have changed. That's how I coded that up. So let's try this and see what happens. My first test is still going to fail. I didn't fix it. Oops. And so I forgot something here. In order to tell it that it's a test, I need to include this in front of the method. So you see it only saw my first test down here. I need to include this so that it spots the second test, and now we can try again. Except where's my second test? Maybe it's not proceeding because the first one fails. That's not right. It should save for me automatically, actually. Where's my second test? Let me fix this one and see if that... I thought that it would continue on even if it failed, but apparently that's not the case. Let me see. It says 2 of 2. All tests pass. Where are my actual tests? That's what I want to see. It should tell me the actual... I wish I could see the actual tests. Sorry. I'm also a little new to IntelliJ, actually. Huh. I mean, they pass. That's a good thing. Let me change this so that it fails and see that if it's actually working. Okay, so it is running. Yeah, it's running both tests. So now add memory fails and it tells me. It's just not telling me if a test passed, it's got nothing to say to me, right? It's only telling me when a test fails. So, you know, testing using code is very convenient. I can change a class and then rerun my tests and make sure that I didn't break anything. That's a nice thing to be able to do. Like I said earlier, it's nice to write these ahead of time and then write your class, and hopefully more tests will pass as you start fleshing out the class, fleshing out the template. The downside of testing in this way is I can have bugs in my tests just like I can have bugs in my classes. So, you know, if I write my tests wrong, the test could be failing because of poor test design, not because my code is poor, right? So you have to be aware of that. Tests really should be kept simple, right? Don't try to test too much. Test one method at a time. Don't test a whole bunch of your methods in a single test. One test, one method, right? Any questions? That was about all I had. I'm happy to do more if there's any questions.
out really quickly, it erases.
Oh,
Does it erase the computer?
yes. Great question. Thank you so much for asking. I should have mentioned this earlier. So within a class, right, if I create variables, I'm switching back to the class. The same true for a test, but I want to show you this within a class. Let's say I create a variable here. Int blah equals 2, right? I can use this variable within the method. As soon as the method is over, that variable is gone. I can't use it anymore. It's called a local variable. The same was true within C, right? Any variables I created within a function in C were gone. I couldn't get to them outside of the method. The same thing is true, right? In Java, the difference is these properties that I stick at the top of the class file can be accessed from any method that I want. So you'll hear some people say these are global variables of sorts, right? Because they can be touched from any method. So you should really kind of consider that as you're creating your classes. Does this need to be global? Can I use that has a relationship to describe this attribute? Or is it just something that I need for the purposes of this one particular method? In which case, keep it in that particular method. We always want to defer to local variables if we can, right? We don't want to create things global unless we absolutely need them to be. Unless we can use that has a relationship, they should not be properties. They should not be globally accessible variables. Great question. Thank you for asking. What other questions can I answer? Okay, I'm going to stop the broadcast right now since that's pretty much done.